Welcome to the Bearded Math Man's YouTube channel. Hey, in this episode, what we're going to be talking about, rearranging formulas. It's a great application of algebra. Whether or not you find inverse operations to be easy or difficult, this exercise, this topic, offers something great for you. If this is easy for you, then this is the next step. And if inverse operations have proven difficult to this point, sometimes you can find some clarity in a new application of something that's been confusing at a different level. So what we're going to be doing, we're going to be able to learn how to solve something like this right here for the variable of h. We're going to learn how to solve something like this for y or y1, whatever. So let's get into it, shall we? We're going to start off with a conversion formula from Celsius to Fahrenheit. So Celsius, the temperature, is the same as Fahrenheit if you subtract 32 degrees from the temperature in Fahrenheit and then multiply by 5/9. So you know how this works. If you knew the Fahrenheit temperature was 68 degrees, you'd plug in 68 for F, you would subtract, you would multiply, no problem, right? That's just the order of operations, PEMDAS. That's how we use it here where I live anyway. But what if you needed to figure out what is the temperature in Fahrenheit if the temperature in Celsius was in fact 20 degrees? Now we know the answer is going to be 68 because we've got it right here, right? But doing the math is a little trickier because now we have to do inverse operations, right? So we plug in 20 for C. We have two choices. We can distribute 5/9, but 9 doesn't go into 32, so we'd have an ugly fraction. Or we could multiply by the reciprocal, which is what I would choose to do. 5 goes into 20 4 times 30. 4 times 9, 36, right? And then you just add 32, and you get 68, right? Now, that's an application of finding out the formula for Fahrenheit given a specific temperature in Celsius. But what if we just wanted to figure out the formula for converting from Fahrenheit to Celsius? You know, if we're given this formula right here and asked to solve for F. Well, we're going to use inverse operations, and we're going to do the same exact steps as we just did. We're going to multiply by the reciprocal, so we're going to have 9/5 times C. 9/5 times 5/9 reduces, and then we're going to add 32, and boom, we're done. So that's what rearranging formulas is really about. It's just an application of inverse operations, but the thing that makes it tricky is we don't always have the arithmetic facts to fall back on, so we have to be good at reading and writing math when we can't do any further simplification. So let's take a look at something that might seem kind of silly for math. If we read Bob plus Jones equals me as English, well, that doesn't make much sense. But if we read it as math, this is B times O times B plus J times O times N times E times S equals M times E. And because of the associative property, or the commutative property, I should say, of multiplication, you can rearrange it. M times E is the same as E times M. Boy, if that was true for English, boy, spelling would surely be a lot easier, right? You could mix up I before E all you wanted and it'd be the same thing. Anyway, let's go ahead and solve this for N. Now, once again, we're not reading this like it's English. We're reading it like it's math. When things are next to each other like this, that means multiplication. Of course, when you have a plus sign, that means addition, right? So the trick is we have to figure out, well, what is keeping N from being by itself? Well, we have all these letters, B-O-B, J-O-E-S. We have to figure out what all of them are doing mathematically to the N. Now, while it's true the B and the O and the B are all multiplying together, that entire term is adding with the N. And the J-O and the E-S, well, those are multiplying with the N. So we have to use inverse operations to get rid of this term, and then the J-O and the E-S. So the opposite of plus B-O-B is to subtract it, right? And the opposite of times J-O-E-S is to divide by Joe's. I know it's not really Joe's. It's math, not English, but hey, let's roll with it now, shall we? So let's go ahead and do this. If we're going to use inverse operations, like we just said, the opposite of plus B-O-B is to subtract B-O-B. If we do that from both sides, this makes 0. And we're left with J-O-N-E-S equals me minus Bob, right? Now, we have to divide by J-O-E-N-S. We can do that all at once, just like this. And on the left, everything reduces except for the N, and we're left with N equals ME minus BOB divided by JOES. Now, this is math, not English, so b times b, you can rearrange those. That would be b squared, right? Yeah. Here's the key idea. I know this might seem kind of silly, but it's a great example to get you used to reading math for its operations. We have no ability to rely on arithmetic facts here. We just have to rely on our ability to read and interpret math as a language. So the key idea is just that. You have to read for understanding of what is there. You have to decode the information and make sense of the operations. You cannot read these equations, these formulas, and think, oh, what do I do first? Instead, you have to figure out what's written. What is the meaning of what is written? And then how can you use that to answer the prompt or answer the question that's been asked? Let's try another example, shall we? So you know this thing right here, right? The slope formula? You've seen it before, surely, right? Well, what if we knew what y2 was and x2 and x1, and we knew the slope as well, but we wanted to solve for y1? Could we do it? Of course we could do it. Here's what we're going to do. Here's the thing. You see this right here, this y2 minus y1? The y1 is in there, but the problem is the whole thing, this entire group, is a group. And the reason it's a group is because it's being divided by this thing right here, x2 minus x1. And so our very first step is we're going to have to take care of that group operation. The opposite of division is multiplication. No big deal, right? After we're done with that, well, this is actually a plus y2, so we're going to have to do the opposite of that. We're going to have to subtract, and we're going to be left with a negative y1. Now, when you're multiplying or dividing, and you're using inverse operations, you want to get a positive 1 times that thing. So if we have a negative y sub 1, and we want it to be a positive y sub 1, we just multiply by negative 1. But what you do to one side, you have to do the other. So let's go ahead and apply these, shall we? Our very first thing is we're going to take care of this group operation. We're going to multiply both sides by x2 minus x1. On the right, they're going to reduce, and on the left, well, this is what we have. We could distribute, or we don't have to. Now our next step is we're going to go ahead and subtract y sub 2 from both sides. Makes 0 on the right, and on the left, this is what we have right here. Our very last step, we have to multiply both sides by negative 1. And what's going to end up happening is I'm going to rearrange this on the left so that our first term is positive, and over here on the right, it's positive. And there you go. Signs are tricky. They're a little confusing. If that doesn't make sense to you, take a minute and think about it. Write it out. I didn't show every single possible step here, but if you need to see more steps, go ahead and try it one step at a time. Go ahead and rewind the video and go back to each step and try one at a time and mess with it. Make sense of it. Take your time. Be patient. You can get this. All right. Now, there is one new topic that we're going to learn, and it's called what the factor. That's right. Factoring. Factoring is the opposite of distribution. So, for example, if you had A times a quantity B plus C, of course that's A times B plus A times C, right? Well, what if you had this, A plus B times A plus C, and you're trying to solve for A? Those aren't like terms. You actually cannot add them at all. You're kind of stuck. Well, here's the thing. If it's true one way, well, then it's going to be true the other way. If you started off with A plus B, A times B plus A times C, you could divide out an A from both of those terms and get this thing here on the left. And we're going to use that as an example right here when we're going to solve for A with 5 equals AB plus AC. Now, once again, you cannot add these together. They're not the same. So what we have to do to get A by itself and just having one A, we have to factor. We're going to divide A out of both of those, and we're going to write that as a product of A times the group, B plus C. If you were to distribute this A, you would get back this thing right here, AB plus AC. Now, we need A by itself. It's multiplying by that group, A plus C, or B plus C. So we're going to just divide both sides by B plus C, and we are done. All right, now, let's try another example of that. Why don't you try this one? You go ahead and try it. Solve for O. You're going to have to factor. Give it a shot. No, really. Go ahead, try it. When you're done, I'll be here. I'll be waiting. All right. Did you do it? I hope so. I mean, you're not going to learn by watching, and it's the same thing as the last one. Well, let's go ahead and get started. Here's what we're going to do. We're going to divide the O out of both BOB and Jones, Jones, right? Now, I'm going to write b times b as b squared, but if I were to distribute this o to b squared, I would get b times o, and you can rearrange that all you want. Same thing, right? And the same thing here. JONES in math would be the same as OJNES. All the same thing, right? Now there's only one more step. This O is multiplying by the group. We need O by itself, so we're going to divide both sides, and boom, we are done. That's not so bad, right? Factoring. Man, that's a powerful thing. That's going to be a key thing to develop later on in math. This is just an introduction. We're really going to get into that later on in an algebra class, but for now, just simple dividing out, undistributing, doing the opposite of distributing. It's called factoring. And if you have more than one of the thing you're solving for, and you cannot combine like terms, that's what you're going to do. You're going to factor. Now let's try a tricky one. Let's solve this for E. Well, this is tricky because we have an E on the left and we have an E on the right, but we're not going to be done unless we have E equals something, and that something can't have an E in it. So somehow or another, I've got to get these two together, and there's an equal sign in the middle, so I can't factor it. So what I'm going to do is I'm actually going to take this entire term, I'm going to subtract it from both sides. And the reason I'm going to move the JONES instead of the ME, if I move the ME to the side on the left where the JONES is, well, then I'd have to get rid of Bob, and it's more steps. I'd have to subtract the BOB to move it to the right. So I think it would be easier in this case to move the Jones, if you will, right? So I'm going to go ahead and subtract that. Now, from here, it's really not any different than the last problem. We have an E in each of those terms, and so we're going to divide that out. And then all you got to do is divide, and you're done. That's it. So what was tricky? What's new? What's easy? What was old? Give yourself a chance to summarize what you've learned today because it's going to help you with your recall. Now, if you would like to have access to some practice problems and some notes and some further help, I will leave a link in the description below to my website, thebeardedmathman.com, where you can access all of that stuff. Leave me a comment below if you found this to be helpful. If you're confused by something, let me know how you're doing. Anyway, I hope you found this video to be helpful. Give it a like, a thumbs up if you did. Subscribe. What's to lose? It's free, right? And anyway, hope you have a great day.